All right, welcome back to Note J. We'll call this part 2. We're going to pick up on problem number 5. It says, entomologists are biological scientists who study insects. Entomologists studying tree crickets have found that they chirp at different rates depending on the temperature. The number of chirps per minute C that the tree cricket makes is linearly dependent on the temperature T in Fahrenheit. The crickets do not chirp at all below 39 degrees, and at 67 degrees, they chirp about 126 times per minute. So they give me the variables in this problem again. They tell me that C is going to be the number of chirps per minute. Number of chirps per minute. And that capital T is the temperature in Fahrenheit. So we've got to keep this in mind as we write our function, and we're using function notation. So part A says express the number of chirps C as a function of the temperature T. Be sure to use function notation. So when they remind us to use function notation, they're making sure that we are writing C of T instead of Y. Also, keep in mind that they specifically use a capital C here and a capital T. That will be important to make note of and pay attention to that in your homework problem, not just in this one, but all of them in terms of making sure that the capitalization is correct, or if it's lowercase, make sure you also type it lowercase. All right, so it says in this problem that the crickets do not chirp at all below 39 degrees. Now, keep in mind that in this problem, my function notation is C of T. That means that C is acting like my Y, and that T, the temperature, is acting like my X. So when we think of this as a point, we're looking at this as a point as T, comma, C. So when I take that information that says the crickets do not chirp at all below 39 degrees, as a point, that's actually going to be written as 39, comma, 0. Okay. Notice that this is not my y-intercept, so it does not give me my b value. Okay. It goes on to say that at 67 degrees, they chirp about 126 times per minute. So as a point there, we're looking at 67, 126. So unfortunately, we don't have slope and we don't have the b value, but because they give me 2 points, we're going to be able to find our slope, and then we can plug in to find the b value as well. All right, so let's start with slope here. We've got m equals 126 minus 0 over 67 minus 39. And this is going to give me 4.5. So I now have that my m value is 4.5. I'm going to make a little note of this over here on the side. All right. So at this point, we know that C of T equals 4.5 T plus B. But now we need to find our B value. Okay. Remember, to do this, we can plug in one of the points. 39.0, in my opinion, is definitely the better of the 2 points to choose here. It'll just be a little bit easier to work with. But you can pick any point you want. You're just going to stick with it and go with it and make sure that you plug it in correctly. So on that point 39.0, I'm going to plug that in, and I'm going to get that 0 equals 4.5 times 39 plus b. This is now going to give me 0 equals 175.5 plus b. And now to get that b by itself, we're subtracting 175.5 from both sides. And we're going to find that negative 175.5 is my b value. So I've got all the pieces I need. Let's put them together. Sorry, I'm crunched for room here, so I'm erasing as we go. All right, we are looking at C of t equals, my slope is 4.5 times t, and then I have minus that b value of 175.5. Here is my C of t function. Now, in part B, it says how many chirps per minute will crickets make at 87 degrees. So we are plugging in 87. We're looking for C of 87. That's going to be 4.5 times 87 minus 175.5, which will give me a total of 216 chirps per minute. All right, here's a little information that's going to set us up for the next problem, number 6. Just good information to know ahead of time. It says that manufacturing companies usually have 2 types of costs. So they have fixed cost. Sometimes these are also referred to as overhead. And they're costs that are not related to the number of items that are manufactured. So no matter what, you have to pay the fixed costs. This could be things like rent, a base level of utilities, a base level of salaries, and these things have to be paid even if the company doesn't make any products. We also have variable costs, and this is going to depend on the number of items manufactured. So this is going to include things like parts and raw materials for the products, higher utilities or higher salaries as products are manufactured. So, keeping that in mind, as we look at number 6, it says that a manufacturing company increases the number of items it produces. The fixed costs do not change, but the variable costs increase. So this makes sense. One company manufactures high-end racing bicycles. The monthly fixed costs are $3,615, so no matter what, we've got that fixed cost of $3,615. The total cost to manufacture 25 bikes is $20,990, and we're going to assume the total cost C is linearly related to the number of bicycle X that the company manufactures. So we're going back to a cost equation. We're looking at C of X. It tells me that C is my total cost and that X is my number of bicycles. Okay. It also tells me that I have fixed costs of $3,615. So think about what this means in terms of fixed costs. This means that when no bikes are produced, my fixed costs are still $3,615. So when we write fixed costs as a point, we're actually looking at 0, $3,615. So no bicycles are produced and that fixed cost still remains the same. Now, they also give me another point and tell me that when 25 bicycles are produced, that it costs $20,990. Okay. Now, notice something about that first point. This is my y-intercept. So I actually know that I have a b value of $3,615. All right, so I already have my b value, off to a great start. In order for me to write this cost function c of x, though, I still need my slope. Okay, so let's calculate our slope. We are going to have that the slope is 20,990 minus 3,615 all over 25 minus 0. And this is going to come out to be $695. Okay, so my slope is $695. Now, I'm actually going to jump ahead and look at part C since we just found the slope. Part C asks for the cost to produce each additional bike. The significance of $695 is that is the cost to produce one bicycle. Okay, so the cost to produce each additional bike is $695. All right, jumping back up to part A, we have all the parts we need. We've got our slope, 695, and we have our B value, 3,615. So let's write our cost function. C of x equals 695x plus 3,615. All right, part B wants to know the cost to manufacture 36 bikes. So we are plugging in 36. We're looking for C of 36, which is going to equal 695 times 36 plus 3,615. And this is actually going to give me a whopping 28,635. So the total cost to manufacture 36 bikes is $28,635. All right, I hope that helps on number 6. Let's look at number 10 now. All right, number 10 says in Washington County, the fine for speeding is $100 plus $12 for every mile per hour over the speed limit. On a certain stretch of road, the speed limit's 55 miles per hour. Determine the function f of s that gives the fine if a person is driving s miles per hour. Make sure to use function notation. All right, so let's talk about our variables. We have capital F, which is our fine, and we have lowercase s, which is our miles per hour. All right, so it tells me that I am going to pay a fine of $100 plus $12 for every mile per hour over the speed limit. All right, so a couple things to talk about. No matter what, we're paying that $100. That's the fee that we've got to start at. So that's a lot like our fixed costs when we're talking about manufacturing. So when we look at this, that 100 is like the point 0, and that's going to serve as our y-intercept. So 100 is going to be our B value, okay? And it's $12 for every mile per hour over the speed limit. So we've got to set up an expression here. For example, the speed limit's 55. If I go 56, I'm going 1 mile over the speed limit. If I go 59, I'm going 4 miles over the speed limit. So what we need to do here is we actually need to set up an expression for every mile over 55 miles per hour, and that's going to be represented by S minus 55, okay? So as I set up this function, okay, f of s, I know that my slope is 12 because it's $12 for every mile per hour. So 12 represents our slope, but we have to have that expression S minus 55 so that the people are only getting charged $12 per mile they go over. But then still, no matter what, they have that $100 fine to start out with. So this is the expression we are looking at. But the question asks us, if a person is driving 67 miles per hour, what is the fine? So we've got to plug in 67 into the function that we just came up with. So f of 67 equals 12 times the quantity 67 minus 55 plus 100. And we are going to find that that equals $244. Okay, now the second part here says, if a fine comes to $160, how fast in miles per hour was the person driving? So we're going to take that function we came up with at the beginning and set it equal to $160, and we actually need to solve for S. So we're going to have 12 times S minus 55 plus 100 equals 160. And now we need to solve this equation for S. So let's start by subtracting 100. We have 12 times the quantity S minus 55 equals 60. Let's go ahead and divide by 12 now. And that's going to give me S minus 55 equals 5. And last but not least, we need to add 55. And we get that S equals 60. So we are looking at 60 miles per hour will result in a fine of $160. All right, last one, number 11. Okay, number 11 says that a company discovers that to produce X equals 850 new electronic parts, it will cost Y equals $49,400. To produce 810 new electronic parts, it will cost $47,240. Compute the average rate of change of the cost and choose the most accurate statement from the following. All right, so we discussed briefly in class when we talked about notes I that average rate of change is calculated like slope is. So we're looking at the change in cost over the change in production, okay? So we are looking at 49,400 minus 47,240 all over 850 minus 810. And when we do this, we end up with 54. Okay. Now, there's actually a typo in the slide we need to fix, because both of our options below actually say 56, and we need them to say 54. So we're trying to figure out what the most accurate statement is. The cost is increasing at a rate of $50 per item, or the cost is decreasing at a rate of $54 per item. So if at 810 it costs $47,240, and at 850 it costs $49,400, we can see that to produce more items costs more. And we also found that when we calculated this average rate of change, that it came out to be a positive number. So this represents to us that our cost is increasing at a rate of $54 per item. All right, I hope that helps you with Notes J. If you have any questions, of course, reach out to me. As always, ask questions. I'm here to help. Bye.